The last part of these notes, similarly to with population proportion, is I want to know the sample size needed to estimate the population mean within a given margin of error. So the sample size required to estimate the population mean with a level of confidence 1 minus alpha times 100% with a specified margin of error E is given by this formula. N equals Z sub alpha over 2 times S over E squared. That is a Z, which means I'm going back to using my normal distribution chart. So I have my normal distribution chart pulled up. You can either dig yours out. If I need to upload one to the Google Classroom, I can. Just let me know. But I'm using my normal distribution chart because that is a Z. And then N is rounded up to the nearest integer, so it's always rounded up. So example 5 says, consider the problem, again, with estimating the miles per gallon of a 2007 Ford Taurus. How large a sample is required to estimate the mean miles per gallon within 0.5 miles per gallon with 95% confidence? So let's talk about all the different variables that I need. I'm looking for N. I need to know Z sub alpha over 2. So let's start by determining alpha. So alpha it's 1 minus alpha times 100%. So if I look at this confidence interval, 95%, that means alpha is 0.05. So alpha over 2 would be 0.025. So I would take 0.05 divided by 2, 0.025 for alpha over 2. So Z sub alpha over 2 means what is the Z-score such that the area to the right of that Z-score is 0.025, which means the area to the left is 0.975. 1 minus 0.025. So what is the Z-score such that the area to the left is closest to 0.975? So I'm going to go to my normal distribution chart, and I'm looking in the middle for what's closest to 0.975. So what's closest to 0.975 is actually exactly 0.975, which is 1.9. I don't think I can scroll here. 1, 2, or 0, 1, 2, 3, 4, 5, 6. So 0.196 is the Z-score. So Z sub alpha over 2 is 1.96. So that's important. And then I need, what other variables do I need? I need an S and I need an E. And then I need E. Well, we'll start with E because E is in the problem. The margin of error, I want it to be within 0.5 miles per gallon. So we're not dealing with percentages anymore. I don't have to worry about moving the decimals. E is 0.5. As far as S goes, S is the sample standard deviation. So these 13 cars, I've already input into my my list here. So when I go to tests and I go to T interval and I input and I go back over to data, this L1, the frequency, the 95% confidence, it'll actually tell me the sample standard deviation. Or if I calculate one variable stats, it'll also give me the sample standard deviation. The sample standard deviation, S, is 3.21, whichever way I go. So the sample standard deviation is 3.21. And so I'm going to plug in all of this information into this formula. N equals Z sub alpha over 2 times S over E squared. So N is, that's not what I meant to do. I need to scroll. So N is equal to 1.96 times 3.21 divided by 0.5 squared. So when I take 1.96 times 3.21 divided by 0.5 squared, I get that N. I have to round it up to the next integer. So even though it's only 0.3, I still round up to the next integer. So I would need 159 cars in order to estimate the mean miles per gallon within 0.5. So